In this video, we're going to talk about introduction to functions. So our learning objectives are to evaluate functions using function notation, identify if a relation is a function graphically, and identify different types of discontinuities. So first, we're going to talk about other types of names or other names for input and output. So the input is also known as our independent variable. It's our domain. And we also use the variable x to represent the domain. Our output variable, or our output, is our dependent variables. It's also our range, and we use y to represent that. Okay, so why do we need to know this? Because in function notation, it helps explain the different parts. So the first part is the variable or the letter that we use. That is the name of the function. It can be any letter of the alphabet. The most common one used is F, but again, it could be H, G, J, K, any letter of the alphabet. Then we have our input value or our X value inside the parentheses. That's just telling us what variable we're using. And on the outside, we have an expression of X, or an expression in terms of X, which is our output variable. Okay, the reason we have that is because if we plug in different values for X, that's going to give us a dependent variable, okay, our Y value. So in our example, we're going to practice plugging in values. So if you notice, I have the function f of x equals x squared minus x plus 1. And now, instead of x right here, it has a 2, which means each one of these x's is going to change to the number 2. So what I'm going to do is I'm going to write parentheses squared, because I'm going to square some number, minus parentheses plus 1. Everything that is left open here and here was originally an x variable, but now we're going to change it to this number right here, which is 2. So I have 2 here, I have 2 here. So now I'm just going to simplify using order of operations, which means I do exponents first. So 2 to the second power is 4. I have minus 2 plus 1. So when I add 4 minus 2, I get 2 plus 1, I get 3. So f of 2 is equal to 3, and that would be my final answer. Okay, trying this one right here using the same equation. I am now inputting 3 in for every x. Again, I'm going to use parentheses to make sure that there's no typo. So I have a negative 3 in for that x, a negative 3 in for that x. Now I'm going to simplify. Negative 3 to the second power is a positive 9. Negative times a negative 3, or minus a negative 3, turns that into a positive 3. A double negative turns into a positive plus 1. So 9 plus 3 is 12, plus 1 is 13. So f of negative 3 is 13. Moving on to the last one, go ahead and pause the video and see how you do, and you can check your answer. So this time we're going to plug in negative 1. So I have parentheses squared minus something in parentheses plus 1. Again, we're plugging in negative 1 for x. So negative 1 to the second power is a positive 1. A double negative turns into a positive 1 plus 1. And when I add 1 plus 1 plus 1, I get 3. And that would be the final answer. So if you have any questions on function notation, make sure you write them off to the side. Lastly, we have the next part is identifying functions. So a relation is a function if every x value corresponds to exactly one y value. Basically, what that's telling us is that our x's can't repeat. To determine this on a graph, we are going to use what we call the vertical line test. This is a graph that is a function, or it says a graph is a function if any vertical line drawn through the graph intersects the graph at no more than once. Okay, so if I have this vertical line right here, and I take this vertical line and I drag it along my graph, is there ever going to be a time that it hits my graph more than once? And right here, it does. Notice that it's hitting here, here, and here. This tells me that this graph right here is not a function because it's going to fail the vertical line test. So since it fails the vertical line test, then that's it. It's not a function. Looking at the next one. So again, I'm going to draw my vertical line in, and I'm going to take it and I'm going to drag it along to see if it ever hits anywhere on my graph more than once. And as I drag it through, I see that is not the case. So this one is a function. Okay, I go to my next one. I draw a vertical line. I'm going to drag it along to see, and I go and I see that it's hitting something or hitting two spots in the circle. So this is not a function. Okay, now what I would like you to do is to pause the video and try D and E on your own, and then we'll come back and talk about F together. So hopefully you gave D and E a try. I'm going to go ahead and draw my vertical lines in, even on F. So if I drag the vertical line on graph D, notice that it's never hitting anywhere on the graph more than once. So this is a function. Okay. When I drag the graph on E, notice that my vertical line is never hitting the graph at more than one spot. So E is also a function. As I drag my graph or my vertical line on F, moving on, okay, I would assume that maybe here we might have some issues. But because this is open and this is closed, it's not hitting two spots on our graph. So that part is okay and it's allowed. But if I keep moving and moving and moving, right here is where there's an issue. So notice how I have part of the line here and then a closed circle here. If that circle at the bottom was open or there was another hole in the graph, this would be okay, but it's not. So this part makes it not a function. That is the only part of this that makes it not a function. Okay. So if you have any questions about the vertical line test or a graph representing a function, please make sure you write it down and you ask in class. The last piece actually this time is now talking about continuous functions in different discontinuities. So a continuous function is a function that has no breaks or gaps in its graph. You can draw without ever lifting up your pencil. Okay, so if I try to trace graph D, then I could start here and graph it and never have to pick up my pencil. But if I tried to graph F, I'd have to stop here, pick up my pencil and move, and then stop here and move as well. So D and E would be continuous functions because I can draw them without ever lifting my pencil. F is not because I have to jump to different parts of the graph. So this leads us to our three different types of discontinuities we are going to see. The first type we have is removable discontinuity. So this right here represents removable discontinuity because it's like we removed a part of the graph and now there is a hole there. So this is removable discontinuity. So I'm going to abbreviate. And it's going to be at x equals, and this x value is -1, -2, -3, -4. So at x equals -4. And that would be the type of discontinuity this graph has. Looking at the next one, okay, notice that I have both of these arrows going up towards positive infinity, but they're never going to actually touch this y-axis right here. So this is infinite discontinuity. Again, I'm going to abbreviate discontinuity. And that infinite discontinuity is happening at x equals 0. Okay. Looking at the next part, I see that my discontinuity is happening here. And it looks like I'm jumping from one function to another. So this is jump discontinuity. Again, abbreviating. And this happens at the x value of 3. So those are the 3 main types of discontinuity that we need to be able to identify. So what I would like you to do is to stop or pause this video and try to find the different types of discontinuities and at what x values they happen for this graph right here. So I look and I see that it has a discontinuity here and a second discontinuity here. So this first discontinuity, I have 2 different graphs and I'm jumping from one graph to the other. So this is going to be at x equals -3. There is jump discontinuity. Again, abbreviating. And then at x equals 1, it looks like we removed a piece. So there is going to be removable discontinuity. And that is the only type of discontinuity that occurs on this graph. So if you have any questions, please make sure you write them down and you ask in class. And that goes for any of the topics that were covered in this video.